4 measures of spread. Okay, range, you guys know about biggest minus smallest. Take the biggest number minus the smallest number, that's the range. Okay, not hard. Interquartile range, we talked about that last week. IQR is Q3 minus Q1. It's the middle 50%. It's the box, edge of the box to the edge of the box. Okay. The 2 new ones are down here. One is called standard deviation. It's a measure of spread that we use with the mean. The other is called variance. Variance we don't really use a lot, but sometimes that word will pop up and you're like, what the heck's variance? It's standard deviation squared. So square the standard deviation, that's variance. It won't come up a lot, but it has come up in the past. So I just put it on the notes just so that you know what it is. Okay. All right. Okay. So anytime we're comparing or describing a distribution, we always have to address each of these, just like we talked about. Okay. We've talked about shape. It's the first thing we talked about. Then we talked about center. Then we talked about outliers. Now the last thing is spread. We've talked about IQR. We just haven't talked about standard deviation. Standard deviation is one of the things we're going to use, one of the statistics we're going to use the rest of the year. From now until the last day we're done, the last day we're teaching new content. So it's super important. Okay, that's why I take a whole day to do it, because it's super important. Okay, so what I want you to do right now is I'm going to give you a few minutes. I have 2 data sets. Using your calculator, tell me the mean and the median for each, and then explain what differences you see. Okay? So 2 data sets, do A and B. Just what's on mine. Just what's on mine. Just do A and B and stop right there. Okay, so the second table probably went a lot faster than the first table. Why? Was that? The numbers were smaller, right? I could do, the only thing I needed the calculator for was the division at the bottom, the division and the square root, right? I didn't need it to add. I didn't need it to subtract, right? The numbers are a lot smaller because why are these numbers in A, or sorry, B? Why are these numbers a lot smaller? What's causing that? What's causing those numbers to be a lot smaller? They're all very, very close to the mean. They're all very, very close to the mean. Even the ones that are farthest away are 5 away from the mean, right? In list A, the closest they were besides 0 was 30, right? They're all a lot closer to the mean. So look at the standard deviations. One is 34, over 34, and one is over 3. One's a lot bigger than the other. Here's my question, test question I would ask you. My list on A, the standard deviation's 34.2. Give me a number that would make that go down. Any number. Big, small, fraction, decimal. What number? Give me a number that would make this standard deviation go down. And why? Why does that number make it go down? Think about it for a second. Don't say anything. Think about it for a second. So focus on list A. List A. Give me a number that would make the standard deviation, this number here, 34.2, go down. And why would it make it go down? Okay. Tell the person closest to you in proximity. Tell the person closest to you what you think and why. I'll give you a few minutes. Go. Who wants to give me there's lots of answers. There are a lot of answers, so not just one. Okay, yeah, Justin. 70. 70. Why 70? Yeah, 70 would definitely make it go down. So if I would add 70 in here, 70 is a new number. How far is that away from the mean? 0. Add 0. This number right here would become 6, right? What happens when this number becomes 6? What happens to this number if this number becomes 6? The total would be lower, right? Which means the standard deviation would go down. Good, 70 works. What's another example of one? 0 would actually make it go up. If I added 0 to the list, it would actually make it go up. Yeah, Kira? 71, definitely. 71 for the same reasons. 72, 73, 74, all of those. Where would the cap be? Where would the cap be? Yeah, what's the biggest number that I could add to this list that would make the standard deviation go down? Let's see. It would be over 99. 150 would be too much. We'll come back to that question. Next thing, probably one of the most important pieces of information you'll have all year long. How to interpret it. How to interpret it. Exactly. How to explain it in words. Those numbers. How do I talk about 34.2 and 3.225? You can't just say the standard deviation is. You got to assume that someone doesn't know what the standard deviation is. So how can I make it make sense to them? This is how you do it. Sentence frame. On average, this is the definition. This is a sentence frame I use for standard deviation. On average, each value in the data set is 34.2, 3.225 units. We don't know what the units are. If they give you units, you should always include that. Away from the mean, which is that number there, whatever number, 70. So what does that mean? On average, each of these guys is about 34.2 points away from the mean. Okay, of 70. On average, these guys over here are about 3.225 points away from the mean, which is 70. What does that mean? So are all of these numbers 34.2 away from 70? Are any of them 34.2 away from 70? What is 34.2 away from 70? 104.2 or lower. So 70 minus 34, 38, 37 point something. On average, each of these numbers is about 34 away from the mean. Does that mean all of them? No, that's why we say on average. When you guys take a test and I say the average score was an 82%, does that mean every single one of you got an 82%? No. It means on average, right? Nobody could have gotten an 82%. That's what this is saying here. On average, each of these guys here is about 34 points away from 70. On average here, each of these guys is about 3 points away from 70. Why does this number have a smaller standard deviation than these numbers here, than set A? Because A is more spread out than B. B is really close together. So if you guys take a test and the standard deviation is 34.2, what does that tell me about you guys? Not necessarily did bad. What does it tell me though? If you guys take a test and our tests are worth 100 points. And my calculator automatically does, my program, my computer automatically does this. This is one of the things I look at. And my standard deviation is 34.2. What does that tell me about your test scores? They're very spread out. They're very spread out. Some people did really, really, really well. Some people did okay. Some people did okay. You know, like some people did better. Some people did okay. Some people, there's all kinds of spread. You guys are all over the place. But if your standard deviation was 3.225, what does that tell me about how you guys did? You guys were all very close to each other. I don't know where that is. Was that an A? Was that a B? Was that a C? I don't know where that is, but you guys were all very close to each other. Okay? That's what standard deviation measures. Okay? So, on average, each value in the data set is blank units away from the mean, which is that. It tells you it's a measure of spread. It's a measure of spread. It tells me what's going on the inside. Okay, what's going on the inside. All right. Let's see here. Okay, so what we're going to do, we're not going to finish this example, but we're going to get it started at least. So go to your calculators, get your calculators out, put those numbers in L1. If you have lists in there, erase them. We'll put those numbers in there so when you come back, we can still have them. So once you put them in, find the mean. Use the calculator to find the mean. Use the calculator to find the mean. Give me 1 second to catch up, and I will. 9, 19, 26, 29, 31, 27, 26. Double check. There's 12 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yep. Okay. I want to find the mean. What do I do again? How do I get to the mean? Stat. I like that. Okay. What do I do next? I want to find the mean. Calc. One of our stats. Where are my lists? My list is in L1. Frequency, don't touch. Calculate. X bar. X bar is the one I want. That's the mean. 24.8. Go 3 spaces. We always go 3 spaces. So 24.833 stays 3 because it doesn't round up. That works too. That works too. You can put a bar over it to say it's repeating. 24.833. Go 3 spaces. Always go 3 spaces past the decimal if you can. If you can't, if it stops, then you can't. Okay. Is there any other symbols there that look familiar? Yeah, the O with the tail, right? The fancy O with the tail. That's the standard deviation. 8.484. Now, when I said you're going to need to, it's important the symbol because I'm going to get on test day, group test day, and Friday, I'm going to get this question on the test. Which one is it? Is it 8.860 or is it 8.848? Which one is it? Which one is it here? Some people will think it's S standard deviation. I use that one, right? No, it's this one here. Test day, I'm going to be like, I can't help you. Sorry. That's why I rate the symbol. Well, I already told you what these guys are, the top 3, and I told you what the rest of them are. If you scroll down, I don't want to tell you what S of X is because it's not necessary right now for chapter 1. It's not necessary. We only use, it's called theta of X. It's the O with the X on it. That's the one we're going to use for standard deviation. Okay, that's the guy we want. All right, that's the guy we want there. One more time. That's the guy we want because I know I'm going to get this question and I'm going to have to say, I don't know on Thursday or Friday. Okay, so just remember, write that symbol in your notes so you know what to look for. Okay. All righty. Okay, so we'll finish out. We'll continue. We'll finish the notes tomorrow. Okay, and then I'll give you the review tomorrow too, probably, so you can start that. All right. We have homework that's due tomorrow. So the assignment I posted on Friday, it's not due till tomorrow at the end of the day.